Eigenvalues and eigenvectors, the special directions that survive a transformation. Apply a transformation to 8 arrows. Most of them change direction. They get knocked off their original line. But 2 special arrows, highlighted in orange, only get scaled. They stay on their line. Those are eigenvectors. Here's the definition. An eigenvector V is a vector that, when multiplied by matrix A, only gets scaled. A times V equals lambda times V. Lambda is the eigenvalue, the scaling factor. The direction doesn't change, only the length. For the matrix 3, 1, 0, 2, the eigenvector 1, 0 has eigenvalue 3. It gets tripled. The eigenvector negative 1, 1 has eigenvalue 2. It gets doubled. Watch. As we apply the transformation, these 2 arrows stay on their dashed lines while everything else moves. Think of eigenvectors as the natural axes of the transformation. Along these lines, the transformation is simple, just stretching or compressing. Everything else is a mix of these 2 fundamental directions. How do we find eigenvectors algebraically? Start with a V equals lambda V. Rearrange to a minus lambda I times V equals 0. For a non-zero solution to exist, the determinant of a minus lambda I must be 0. That equation gives us the eigenvalues. Worked example. A equals 2, 1, 1, 2. The characteristic equation gives lambda squared minus 4 lambda plus 3 equals 0. So lambda equals 1 or lambda equals 3. For lambda equals 1, the eigenvector is negative 1, 1. For lambda equals 3, the eigenvector is 1, 1. Let's verify visually. Apply the transformation. The orange eigenvectors stay on their lines. One scales by 1, so it doesn't move. The other scales by 3. What do eigenvalues tell you? Lambda greater than 1 means stretching along that direction. Between 0 and 1 means compression. Lambda equals 0 means collapse. That direction vanishes. And negative lambda means a flip along that axis. To summarize, eigenvectors are the special directions that only scale under a transformation. The eigenvalue lambda is the scaling factor. You find them by solving determinant of a minus lambda I equals 0. They are the natural axes of the transformation. Thanks for watching. Subscribe to Zari Gatongi for more math explained visually. And visit 8gramswifi.org/math.